Okay, so for this we've got a movable pulley question. Now we're told the weights here. We're told that a 6 kilogram weight hangs off a fixed pulley, and then we've got a movable pulley of 8 kilograms. Now we'll see here we've got different tension. They're the same string, so the tensions are all the same. We've got one tension there, there, and there. All those tensions are the same. They should all be the same length. We're just going to carry on. T, T, and T. Now what happens is that if this was 4 kilograms, there'd be no movement at all, because this would balance that weight perfectly because it's been hinged off 2 tensions, off 2 T. So if that was 4 kilograms, there'd be no weight. Because this is greater than half of it, we know that the net acceleration is going to be down here, like that. And this is going to move up like that. So we'll do our separate force diagrams. So first off we have the pulley. And the pulley has got 2 tensions, one there, and mass times acceleration down. The next one we have is the mass, Q. Now Q has weight down and tension up. So I'm just going to fill these in. So that's tension, tension, and this is 8G, because it's 8 kilograms, 8 times gravity. And this is 6G here, this is a 6 kilogram mass, and this is tension here. Now, the tricky part about this is accelerations. What we have here is, we should just have a little think about it. I'm just going to change the colour there. And we know that this one is going to accelerate down, and this one is going to accelerate up. But because there's 2 strings holding P, it's going to move up half the distance that Q will move down. So this will accelerate, if we call that A, this will have an acceleration of 2A. Now I'm just going to write just a different vector because they're accelerations, not really forces. So if I separate these two out just so that we can see there's 2 separate equations. Now what we have is, on this side here, we have the net force is equal to 2T minus 8G. Net force then is mass times acceleration, it always is, so it's 8A is equal to 2T minus 8G. This one here we have the net force again is equal to 6G minus T. In this case it's going to be, the net force is going to be 2A, because mass times acceleration, but remember that instead of A we're going to put in 2A times 6 is equal to 6G minus T. A little bit of rearranging there, and we have 12A is equal to 6G minus T, and here we have 8A is equal to 2T minus 8G. So dividing across by 2 for this one, we get 4A is equal to T minus 4G. That's equation 1, that's equation 2. If we add them together, so I'll throw equation 1 over here, 4A is equal to T minus 4G. We'll find that the T's cancel, and we get 16A is equal to 2G, or A is equal to 2G over 16, or G over 8. So we have worked out the accelerations, and then it's very simple to work out the tensions. If we just substitute that back in, we get 4 times 4 times is a G over A is G over 8, so 4 times G over 8 is equal to T minus 4G. So that goes to G over 2 plus 4G is equal to T, and T will be equal to, that'll be 8 over 2, so 9G over 2. So in this we've worked out the forces and accelerations of a movable pulley.